In this class, now I am going to explain various forms of equations of straight lines. So before going to start this class, now I am requesting you to subscribe, like and share my channel so that my classes reaches to many people. Now let us go to the class. So the first form of a line equation is the gradient form. Various forms of equations of straight line. See the first one, gradient form. Gradient form, or also you can call this form as slope form. See, consider this Cartesian plane, x dash, y dash. See, here I am taking one locus, group of points. Okay, so this group of points passing through origin. So among these infinitely many points, consider any one point P. Okay, so here it is locus point, so that we have to consider that locus point as x comma y or x1 comma y1, your wish. So here I am taking that point coordinates as x comma y, because this is locus point. It can be taken anywhere on this group of points. Now here we identified 2 points on this group of points. When we connect them, we get a straight line. So here we have 2 points. So when we know 2 points on a straight line, so how to determine the slope of this line, okay? So you have slope formula, m is equal to difference of y coordinates by difference of x coordinates. Here what is the difference of y coordinates? Y minus 0. Here what is the difference of x coordinates? X minus 0. Okay, now let us simplify that. If you simplify that, you will get y equal to mx. So this is known as gradient form or slope form of equation of a straight line. Okay, so here where m represents slope of this straight line. Here m belongs to any real number, either it may be positive or negative or 0. Right, now let us go to the next form of equation of straight line. See, the next one is known as slope and intercept form of a straight line. Slope and intercept form of a straight line. X dash, y dash. So this is origin. Now see, this is one line. It is intersecting y axis at one point. Let us consider this point coordinates 0 comma c. The distance from 0 to this point of intersection is c here, c units. From here to here, c units. Okay, all right. Students, see here. Here it is a one line. So passing through the point 0 comma c, and so here we have to consider one more point, that is locus point. You can take that one point, that point anywhere on this line. So shall I take over here P, locus point? Let it be x comma y. It can be taken anywhere on this line. Okay. Now it is given, and here we consider locus point as x comma y. Again here we know the 2 points. Okay, now determine the slope of this line. Same like previous one, difference of y coordinates y minus 0 by difference of x coordinates x minus 0. Okay, y2 minus y1 by x2 minus x1. No, so apply that formula and simplify this. When you bring this one to the left side, you will get y minus c is equal to mx. When you transfer c to the right side, y equal to mx plus c. Okay, where m is slope of this straight line and c is y-intercept made by this line. Okay, when y-intercept is given, slope of the line is given, in such case you have to use this formula to determine equation of this line. Okay, so what we have to say, this slope and intercept form or slope and y-intercept form of a line equation. Okay, now suppose if x-intercept is given, how you have to determine such line equation? See here, x dash, y dash. Okay students, see here, line is moving like this. Here, this is origin 0, 0. Where it is intersecting x-axis at here, no? Let us assume that point coordinates a, 0. The distance from origin to this point of intersection is small a units. Now same like previous one. One of the point on this line is identified and you consider that locus point as px, y. Now 2 points are given, no? So then apply that slope formula. So difference of y coordinates y minus 0 by difference of x coordinates x minus a. Now let us cross multiply. So what do you get? M into x minus a. So what is this? Slope and x-intercept form of a line equation. When the slope of the line and x-intercept is given, in such case you have to use this formula to find the equation of this line. Y equal to m into x minus a. Okay, right. Next, see, x dash, y dash. This is origin. Now one line is moving like this. On this line, one fixed point is given whose coordinates are x1, y1. And now variable point or locus point you can consider as x, y. One fixed point is given and here locus point I am considering as x, y. So now when 2 points are given, one fixed point and slope is given, how you have to find equation of such line? Okay, same like previous one only. One fixed point is given, locus point we have considered. Now apply the slope between these two points. So that what do you get? M is equal to difference of y coordinates here. Okay, y minus y1 by x minus x1. Now take cross multiplication. Y minus y1 is equal to m into x minus x1. This is known as point slope form of a line equation. When slope of the line is given and one of the point on the line is given, that is called fixed point. When the slope and point is given, in such case you people have to use this formula to find equation of this line. Y minus y1 equal to m into x minus x1. Okay, remember this. Suppose instead of 1 point, 2 points are given like P. So here we have taken, this is P, no? This is take it as A instead of PA, because locus point we have taken as x, y, no? Take it as A, and one more 2 fixed points are given, suppose x2, y2. two fixed points are given. In this case, how do you find equation of this line? See, students, first find whose slope? Slope between AB. M is equal to y2 minus y1 by x2 minus x1. You prepared slope of this line now? Now come to here, instead of m, substitute this slope. So that what do you get this line equation? Y minus y1 equal to y2 minus y1 by x2 minus x1 of x minus x1. Okay. So what we have to call this? 2 points form of a line equation. Okay. So when the 2 points on the line are given, if they ask you to find equation of that line, in such case you people have to use this formula. Y minus y1 equal to y2 minus y1 by x2 minus x1 of x minus x1. Okay. Right. Next. See students, see, consider this point slope form of a line equation. Y minus y1 equal to m. Okay, so students, you know this, m of x minus x1. See, you know, when the inclination of the line is given, this is inclination of the line is given. In such case, how do you find slope of this line? As you know, m is equal to tan theta. Am I right? Even I taught the slope concept in my class. So if you want that slope concept, you can go through my slope concept class. There what you require, related to this slope. So complete knowledge I gave you there. So if you want to follow that slope class, you can search in my channel. You will get that class. Okay, but here I don't want to go into the slope concept. Okay, so you know, when the inclination of the line is given, so you have to use this formula to find slope of the line. Why we have to define with respect to this theta as tan? Why don't we define other trigonometric ratios also? I gave you the reason. Okay, so now m equal to tan theta is the slope of this line, where theta represents inclination of the line. Okay, right. Now here m is nothing but what? Tan theta. Tan theta can be written as sin theta by cos theta of x minus x1. Now sin theta, bring it to the left side, y minus y1 by sin theta, so which is equal to x minus x1 by cos theta. Okay, now students, this is known as a normal form of a straight line. Okay, you know, inclination for theta, okay, so this inclination should be close interval of 0 to open pi. Okay, so students, but here this is, what is this? Symmetric form of straight line. So it is true when theta is not equal to 90, because if it is theta 90, okay, cos 90 0, something by 0 not defined case will come. So that students, okay, here observe that theta should not be equal to 0. Okay, if it is 90, cos 90 0, now take cross multiplication and simplify, you will get x equal to x1. So this represents a vertical line equation, x equal to x1. I explain you this horizontal line equation, vertical line equation also. Okay, I hope you have understood this. So this is known as symmetric form of a straight line. Symmetric form of a straight line. Next, let us go to the parametric form of a line equation. See, in this symmetric form, okay, consider this one as like mod r. This ratio, either it may be positive or negative, so that I wrote mod r. Now equate these two, On equating this, you will get x minus x1 is equal to mod r cos theta. When you transfer x1 to the right side, x equal to x1 plus mod r cos theta. When you remove mod symbol, you have to write x1 plus or minus r cos theta. Similarly, when you equate first and last, you will get y equal to y1 plus or minus r cos theta. Okay, students, y equal to y1 plus or minus r cos theta. So, this represents what? Parametric form of line equations. Okay. See, okay, where we have to use these formulas, I explain you. See, students, x, x dash, y, y dash. One line is moving like this. Here one fixed point is given to you whose coordinates x1 comma y1. And this line is making an inclination theta with x-axis in the positive direction. And they will ask you to find a point on this line which is r units away from this A. So find a point on this line which is r units away from this A. Means that r units either above A or below A. Okay. So from here to here it is r. From here to here it is r. Okay. So let us take this point as P. This is Q. Okay. When you consider here plus, okay, plus here what do you get? X value x1 plus r cos theta, comma y1 plus r sin theta. So you will get this P coordinates. Suppose if you consider here minus x1 minus r cos theta, y1 minus r sin theta. So this formula gives you coordinates of Q. Are you getting me, students? Here point, fixed point is given, and they will ask us to find any 2 points on the same line which should be r units away from A. Means either that required point may be above A or below A. Okay. So in such case we use this parametric form of line equations. Okay. Right. Now let us go to intercept form of a line equation. Intercept form of a line equation. See, students, x dash, y dash. See, one line is moving like this. Okay. So here it is intersecting x axis at one point, let it be a comma 0. Y axis at 0 comma b. 0 comma b. Now this is origin. You know, students, the distance from origin to this point, small a units, the distance from here to here, small b units. 2 points on the line are given. Okay. Now determine this line equation. When the 2 points on the line are given, you know, you have 2 points form of a line equation. Apply that formula. Consider a coordinates x1 comma y1, b coordinates x2 comma y2. Now apply the 2 points form of a line equation. Y minus y1 equal to y2 minus y1 by x2 minus x1 of x minus x1. Okay, students. Now substitute in that y minus y1. y1 value 0. Difference of y coordinates b minus 0 by 0 minus a of x minus x1 a. Now let us simplify this. So if you take cross multiplication, what do you get, students? So this can be written, see, y is equal to here minus b by a. This minus you can write in the numerator. Minus b by a of x minus a. Now bring a to the left side. Ay which is equal to here minus bx plus ab. Now transfer bx to the left side so that you will get bx plus ay which is equal to ab. Now divide both sides with ab. Divide both sides with ab. ab cancel. Now here bx by ab plus ay by ab. Now which is equal to 1. Now bb cancel, aa cancel. Now what is left? X by a plus y by b equal to 1. So this is known as intercept form of a line equation, x by a plus y by b equal to 1, where a represents x-intercept, b represents y-intercept. When x-intercept and y-intercept of the line is given, in such case you must use this formula to find the equation of this line. Okay students, right. Next, students, next we have one more important line equation, that is normal form of a straight line. So already in my previous classes I taught to you that normal form of a straight line. So if you want that normal form of a straight line, you people can search in my channel. Okay, you will get that class. Right. Now let us go to two more points. See, x dash and y dash. See, this is the line. अब it is moving parallel to the y-axis and k units away from the y-axis. Okay, this is origin. So this line is moving how much far away from x-axis? K units. Okay, now determine this line equation. Okay, you know, if any line is vertical, okay, so whose x coordinates are same. If you take any point, so whose x coordinates will be same, you will get a difference in the y coordinates. So on the vertical line, x coordinate of every point is same, hence the equation of this line is x equal to k. If this line is right side of origin, you will get k is positive. If this line is left side of origin, so you will get x equal to minus k. Okay students, observe this line equation. X equal to k, x equal to minus k means that represents vertical line equation, where k represents distance from origin to that vertical line. Okay. Similarly, horizontal line equation. Horizontal line equation. X dash, y dash. See. Now, how is this? It is one line which is passing parallel to the x-axis and k units away from the x-axis. Now it is horizontal line, no? So you know, on the horizontal line, y coordinate of every point is same. Sorry, here y coordinate of every point is same. Y coordinate of every point is same, because that is moving k units away from x-axis. This distance represents y coordinate, no? So you will observe the difference in the x coordinate, but y coordinate of every point is k only. Hence, the equation of this line is y equal to k. Okay. So if it is below the x-axis, so you will get y equal to minus k. Okay students, remember these 2 points. Next, suppose, okay, tell me what is the equation of x-axis and y-axis. X dash, y dash. Okay, so here 1 comma 0, here 2 comma 0, here minus 2 comma 0, here minus 3 comma 0, here you make it minus 1 comma 0. What you people are observing? Y coordinate of every point on the x-axis is 0. Hence equation of x-axis is y equal to 0. Okay. Similarly, okay, what is the equation of y-axis? What is the equation of y-axis? So you will get like 0 comma 3, 0 comma minus 2, here 0 comma 1, What you people are finding here? X coordinate of every point on the y-axis is 0, and the equation of x-axis is x equal to 0. Equation of x-axis, y-axis is x equal to 0. Next, students, right, now see students, x dash, y dash. One line is moving like this, whose equation is given ax plus by plus c equal to 0, and one more line is given, it is parallel to this line and passing through the point px1 comma y1. Okay students, what you have to determine here? Equation of this line. How it is passing through a point px1 comma y1 and parallel to this line. Both are parallel. If the two lines are parallel, you know their slopes are equal. Now what is the slope of this line? Minus a by b. Now this line slope will be also minus a by b. Now we need to determine this line equation now. For this line, one of the point is given and slope we prepared. Now apply the point slope form. Y minus y1, which is equal to m value minus a by b of x minus x1. Bring it to the left side. B of y minus y1, which is equal to minus a of x minus x1. Now transfer this one to the left side. Okay. If you transfer, what do you get? A of x minus x1 plus b of y minus y1, which is equal to 0. So this is our required line equation. It is passing through a point x1 comma y1 and parallel to ax plus by plus c equal to 0. Next, see students, x dash, y dash. Now one line is moving like this. Let us name whose equation is ax plus by plus c equal to 0, and we want to find this dotted line equation. Okay, it is passing through the point px1 comma y1 and perpendicular to this given line. Okay, find this dotted line equation. How it is passing through a point px1 comma y1 and perpendicular to this ax plus by plus c equal to 0. Okay, so observe me how I am going to evaluate this line equation. So okay, what is the equation of what is the slope of this line? Let it be m1. Now m1 is equal to minus a by b is the slope of this given line. So you don't know this line is slope. Okay, let it be m2. Okay, but you have one relation. Whenever these two lines are perpendicular to each other, m1 into m2 is equal to minus 1. Now here m1 value minus a by b into m2 is equal to minus 1. Minus minus cancel. Now m2 is equal to how much, students? B by a. m2 is equal to how much? B by a. Now you have got the slope b by a and you have one point. Apply the point slope form. Y minus y1 equal to slope of our required line is b by a. Now x minus x1. Now let us go to simplify. A of y minus y1, which is equal to b of x minus x1. Now send it to the right side so that you will get b of x minus x1 minus a of y minus y1. Now which is equal to 0. Okay students. So this is our required line equation. B of x minus x1 minus a of y minus y1. So it is passing through the point x1 y1 and perpendicular to this ax plus by plus c equal to 0. Okay. Thank you students.